Next two examples, which we're going to do in 1B4, are preparedness or graphing, essentially. So let's go ahead and run through these examples. And what we have here is we have the function f of x is equal to negative 3 times 2x minus 6 squared minus 7. Well, we want to recognize that this is another even power function, x squared. Okay? And we're going to rewrite this as our generic function. So we're going to have the negative 3 here. I'll go ahead and put the f. And what we're going to have to do is we're going to have to factor out this 2 because the leading coefficient has to be 1. So out comes the 2, and we're going to have x minus 3. Close that parentheses. And we're going to translate down 7. And we're just going to capture this. We're going to have a vertical stretch, a horizontal shrink, and translate right and translate down. We're just going to capture this on this table. Again, you're going to eventually get away from these tables somewhat, maybe. They're pretty good. I would probably keep using them. So we're going to shrink horizontally by a factor 1/2. So we're going to shrink, okay, by 1/2, and that's what's going on with this right here. Okay. We also have a vertical stretch of 3. So we're going to stretch 3. And we're going to reflect across the, we're not going to reflect across the horizontal, we're reflecting across the vertical, across the x-axis, because of the negative in front of the 3 over x-axis. Okay? And then we're going to shift. We're going to shift right 3 and down 7. So we're going to have right 3 and down 7. And these tables help out a bit. Okay? Now here's something that we haven't practiced a lot of. We're going to write the equation just for the impact of the x-coordinate. And as you can see, we're multiplying the x-coordinate by 1/2, and then we're going to move it to right 3. So it's going to be 1/2 x plus 3, and this is going to take a little bit of practice on your part. 1/2 x plus 3 to write these little equations. I taught this slightly differently when I was at my last school when I taught Algebra 2, but this method works pretty darn well, so we're going to stick with this. So we're going to have y is equal to f of y, and of course I could have put f of x right here, okay, and is equal to f of y, okay, and I'm going to do negative 3y because I'm going to reflect and the factor is 3, and of course I'm going to move it down 7. And all we're going to do is we're going to fill out this table and come up with some coordinates. Now for a typical quadratic, we have our x and y. This is going off our parent function. And I tend to do 5 coordinates, negative 2, negative 1. And you're going to need to do 5 coordinates as well. That's going to be a requirement. But you're going to pick easy ones. And this is a table you've been filling out for years now. So this is not new at all. And there's our parent function with our 5 coordinates. Now all we're going to do is we're going to do our x impact, which is simply what we just wrote, the 1/2 x plus 3. And our y impact, which again we just wrote negative 3y minus 7. And we're going to fill in the table. We're going to put in x and find out what we get. So when I do 1/2, I'm only going to do a couple of these, negative 2 plus 3. I get a 2, all right? And then I'm going to put that in. I'm going to get a 2.5. You could easily do this on your own. 3, and you're going to realize you're going up by point because we're increasing by 1. We're going to increase by 0.5 on these. So I'm going to do the same thing for the y. I'm going to input my y, okay? And I am going to, whoops, did I put a negative 4? That should have been positive 4. Silly me. All right. I'm going to put in a 4, so I'm going to do negative 3 times 4 minus 7. And that's going to give me a 19, negative 19. And I would do the same thing for a 1. I'm going to put that in. Now we're putting in the y coordinate. This impacts the y. And we're going to put in negative 10, negative 7, negative 10, and negative 19. All right? And that's pretty much what you're going to be doing on these, warming up to graph. So let's go ahead and take a look at the next slide, next example. So what we have here is another function. And let's go ahead and clean this generic function up a little bit. You notice that our leading coefficient is not set up for our x. So let's go ahead and write this as 1/3. Oops, got to put in the h. I keep forgetting to do that. That's the second time I've done that. Negative 3 times, and we're just flipping it and factoring out the 3, so that's going to be x minus 3. Okay, close the parentheses, 5. And we're just going to focus on this point, and I want to find the answer. You're going to have to show your work. There are shortcuts to this, but the objective of this unit is to practice with our generic functions. No showing work. I don't care what kind of answer you come up with. So what we're going to do is we're going to analyze whether they're stretching or shrinking. For the horizontal, we are shrinking it by a factor of 1/3. Okay? So it's getting flattened out. So we're shrinking it by a factor of 1/3, and we do have a vertical stretch of a shrink of a factor of 1/3. This is going to impact the y-coordinate. So these coincidentally happen to be the same. We are going to reflect across the x-axis. Okay, I'm sorry, over the y-axis. And nothing happened on the x-axis. We're going to shift right 3 and down 5. So we're going to have right 3 and down 5. So let's go ahead and write our function. What we're going to do is equal to f of x is equal to negative 1/3 x plus 3, because we're going right 3. We're shifting it to the right. So this is the impact. You need to practice this because we're looking at this. There's going to be sign differences that you may not be quite used to. So let's see what's happening to our y-coordinate. We're going to input the y, and it's going to be 1/3 y minus 5. A little easier than the last example because we're only going to be dealing with this one coordinate that I asked you to find. And this is going to be a 3. So we're going to input the 27, negative 27 right here. Well, that's just negative 1/3. You could do this in your head. So 1/3 of 27 is going to be 9. Okay? And 9 plus 3 is 12. So we have a 12 right here. And we're going to do something very similar to the y. We're going to do 1/3, and we're going to put in our y-coordinate, which is a negative 3, right? Yeah. I didn't write the negative 3. Negative 3. And we're going to subtract 5 at the end. So that's going to be 3 over 3, 1. So negative 1 minus 5 is negative 6. All right, so that is it. I'll get these examples posted, and then we're going to start graphing these things. Okay.